So in this video, let us learn about gas turbine power plant. So in gas turbine power plant, the hot gases is used to run the turbine. So generally in gas turbine power plant, the three major components are present. What are? First one is compressor, and then combustion chamber and turbine. So in the gas turbine power plant, the hot gas is used to run the turbine, and mainly it is used in aircraft engines, electric power generation, so on. So generally the gas turbines are classified according to different types. So first one is according to the cycle of operations. So depending upon the cycle, it is classified into open cycle or closed cycle, and the gas turbine is classified according to the process, and then it is classified according to the usage and the types of load, and then which is applicable to their applications. So the gas turbine is generally classified into two types. According to cycles, the gas turbine is mainly classified into two types. One is open cycle gas turbine and another one is closed cycle gas turbines. So here in open cycle gas turbine power plant, the three major components are compressor and combustion chamber and the turbine. So 1 to 2 processor is compressor, and 2 to 3 is combustion chamber, 3 to 4 is turbine, and then generator. So here the compressor, in which the air gets compressed and then the hot air is passed to the combustion chamber. So in the combustion chamber, we give fuel to this combustion chamber. With the help of this hot air, the fuel gets combust, and then the hot air is passed to this turbine, which is coupled with the generator, produces electric power. So in open cycle gas turbine, the power plant is normally used compared to other cycles. So in this open gas cycle, the air gets compressed. The compressed hot air is fed to the combustion chamber. In this combustion chamber, the fuel is fed to this combustion chamber, in which with the help of this air, the fuel gets heated. The hot air is then passed to this turbine. So the turbine, here the heat is converted to mechanical output. The turbine, which is coupled to the generator, produces electrical energy. So here the closed cycle gas turbine power plant. So in this gas turbine power plant, the components are compressor, heat exchangers, turbine. So instead of combustion chamber, here heat exchanger is used. So here it's a closed loop. In open cycle gas turbine power plant, it is the compressed air, hot air is fed to this combustion chamber. The fuel gets combusted with the help of this hot air and then fed to the turbine. So the turbine, which produces mechanical output, coupled to the generator, it produces electricity. But in closed cycle gas power plant, the compressor, the hot air gets compressed, which is exchanged to the which is passed to the turbine to the heat exchangers. So here from the turbine, the exhaust heat is again fed to this compressor. So this one is a closed loop of gas turbine power plant. So under closed cycle, the heat, the exhaust heat from this turbine, it gets fed to this heat exchanger. Again with the help of this heat exchanger, the hot air is compressed again, and then it fed to the heater. So the cycle is closed cycle, continuous power loop cycle. So in order to improve the gas turbine power plant, we have to provide intercooler, regenerator and reheater. So here the gas turbine with intercooler circuit. So in intercooler circuit, the low pressure, it consists of low pressure compressor and high pressure compressor in order to maintain the pressure level. So from this intercooler, here the compressed air with the low temperature is fed to this water. So from this water intercooler, the high pressure compressor gets passed to this combustion chamber. In this combustion chamber, the fuel gets combust and then it is fed to this turbine. So the hot air, which hits the turbine blades, it starts rotating, and then hot exhaust steam is fed to this cooler. With the help of intercooling systems, the heat with having high temperature can get cooled, and then it may be recycled for the further process. So this one is a pressure and temperature diagram according to this volume and entropy. So gas turbine with regenerations. So here first one is the compressor part and combustor chamber and regenerator and turbine. So in compressor the same process is happened, the air gets compressed and then it is fed to this regenerator, it generates the heat and then it passed to this combustor in which the hot air gets converted into mechanical with the help of turbine and coupled to the generator it produces electricity. And similarly the gas turbine with reheater, so the compressed air is fed to this combustion chamber in which the fuel gets combusted with the help of air and then it is passed to this turbine one. The exhaust steam is again further reheated with the help of this reheater and then fed to the second turbine and then the hot gas is passed to this cooler. Again the water from the cooler gets compressed with the help of compressor. So the gas turbine with reheater which utilizes the intercooler and maintains the temperature and pressure level. So these are the gas turbine with intercooler, reheater and regeneration. So in order to improve the gas turbine power plant, the cycles may be connected with that means the compressor and combustion chamber and turbine may be reconnect with intercooler, reheater and regenerations in order to improvise the gas turbine power plant. Thank you.